of P and what is the y coordinate of Q? Anyone? We've done this from the first day of classes. I know everyone knows what this equals to and what this equals to.
Limit?
No, not yet. This is just plain algebra. I have a point P and a point Q on f of x.
F of P?
Yes, f of x. So if this is the x, and this is f of x. Perfect. Now what is this? Of course, it's x plus delta x or x plus dx. So now can anyone give us the y coordinate of Q?
F of x of dx.
Both of them. So f of x plus dx or f of x plus delta x. Same thing. Great job. Okay, now for this change in x or for this error in x, what is the exact error in y? So a tiny error in x creates an error in the y values. So the error in the x values creates a corresponding error in the y values. That is denoted, of course, if it's the exact, it will be denoted by delta y. Can anyone tell us what does delta y equal to? I'm going to write it.
F of x minus dx minus f of x.
Yes, so delta y equals f of x plus delta x minus f of x. No discussion there. The exact error, or if you want change, in y value, or in y, triggered by delta x. So here it is. F of x plus delta x minus f of x is exactly delta y. Delta y, I can write it here as well. F of x plus delta x. And these are in the way. I don't want them here anymore. What will I do without whiteout? I will be totally lost. I do have several, so this is gone, I guess. Done and over with. Okay, so minus f of x. Excellent. So for a change in x, or any change in x, triggers a change in y. And this is the change in y triggered by this change in x. Error in x, if you want, triggers an error in y. Excellent. So we have the definition. Now, of course, what do you think I am going to graph next? A wild guess. Not that wild. What do you think I'm going to graph next? Of course, our best friend, the tangent, right? It has to be. The tangent at P. Of course, I'm going to extend, and I just created a right triangle with a tangent. This is the tangent. Tangent line at P. Can anyone give us the slope of the tangent at P? Anyone? Tangent at P? We've done this many times. We know what the tangent at P equals to.
The f of x is the derivative.
Excellent. Of course, it's f prime at this point. F prime of this point is the slope of the tangent line at P. We know that for quite some time. Excellent. Okay, now let's take a look for a moment at this triangle. So the slope of this line is f prime of x. I know that the rise is something, but I know that the run is how much? What is the
Delta
run?
x.
Yes, but since I'm using the derivative, now I will use dx.
Dx.
Excellent. So can anyone tell us the slope of this line without the derivative? Rise over run, correct? The slope of this line, rise over run. Awesome. So let's go back there. So then f prime of x, that's the slope of that line, equals rise over run. And now I'm going to ask you, what do you think this equals to? Another wild guess.
dy.
Yes, of course. There is nothing else that fits in here. F prime of x equals dy by dx. Excellent. So then this is the dy. This piece, of course, this should be. So indeed, this is dx and this is dy. And you can say now, wait a minute, you never told us that these two have also separate meanings. You only said that this was the Leibniz notation and I can use this or this. And we used it in implicit differentiation, etc., etc. You never told us that these two mean, at the same time, mean separate things. I didn't. That's the time to tell you that. So dy, what do you think dy is? Delta x is the exact change. Dx is the differential of x. Delta y, exact error triggered by delta x. What do you think dy would be?
A differential of y.
Exactly. Of y. So what does this mean? It's an approximation. I meant to write two p's in there. Approximation of the actual error is not the actual error. This is the exact and there is no other. But the delta y is an approximation of the actual error. Coming back to my graph, you can say, wait a minute, that's not possible. You're telling me that with this distance, you want to approximate this distance? But this is like 3 times as much. Keep in mind, Q is right here. Q is not here. P and Q are extremely close because this is very tiny. So of course, delta y can be approximated by dy. They're very close to each other. Not in my figure, but Q is right here. So then what do you think from here? Can anyone solve this equation for us for dy? What will dy equal to?
The dx times f prime of x.
Yes, but we always, that's perfect. But we have to write it as f prime of x dx. Two things. We haven't finished here. We're going to apply this concept in a minute. But two things. One, that is the result of what we just did. Can anyone give us a relationship, a potential relationship between these two? Between delta y and dy? And you cannot say equal. Please don't say equal. That's not possible. This is an approximation. What would be the relationship here? You cannot say greater than or equal or less than, because we don't know which one is bigger. So,
Not equal to?
I'm sorry?
Not equal to?
That is true. But I want something else that I can use. We know that they're not equal to. I used that word several times here. Delta y is approximately dy. And that's exactly what we have to use.
Just equal.
Yes, exactly. Now, I will replace these two by what they are equal to. The left one is f of x plus dx. I meant to write minus f of x, approximately f prime of x dx. And yes, we are going to move this term to the other side. And you'll see in a minute what we're going to do with this. F of x plus dx is approximately f of x plus f prime of x dx. Please carve this in stone. This is an important, super important relationship. The other thing I just want to clarify before we apply this concept in problems is the following. Derivative differential. Please give me any function you want. Nothing super sophisticated. I just want to illustrate the difference between these two. Just any function. Make up a function. Any function you want.
X squared plus 2x minus 3.
Perfect. What will be the derivative of this function? Can anyone give?
2.
Say it again.
2x plus 2.
Excellent. What will be the differential of this function? We just have to use the formula. We just have to plug it in. There is no operation, no calculations are required. Just use the formula.
The 2x plus 2 times dx.
That's it. So please understand and remember this, carve it in stone. They're not the same. When we talk about the derivative, we talk about the derivative of the function. When we talk about the differential, we are talking about the product between the derivative and the minor change in x, dx, the differential of x. So please understand this is super important, and this is the second super important concept here. You will see what happens in chapter 5 with the differential. So when we are talking about a function and we want to find its derivative, plain derivative. But when we talk about its differential, we have f prime times dx. Yes, if I have another variable, it would be dp equals f prime of w times dw, of course. It can be anything. But if the variable is x here, I have to have dx. If the variable here is w, I have to have dw. So these must be the same variable. Okay, so let's see what we do with this. And then we have one more tiny topic to look at. I did not discuss this yet. I always start with approximations. I'm sorry, with the differentials, and then come back. Okay. I like to use differentials to estimate the given number. So this is one application of differentials. So let's choose anything catches your eye between 31 and 36. Or we can also look at 37 to 39. They're the same thing. So please choose anything you'd like from here.